So what if I told you that you don't actually see the world as it really is? That right now, your brain is kinda lying to you, editing reality before you're even aware of it? Okay, let's get into this.
Take a really close look at this checkerboard. I'm about to tell you something that's going to sound completely impossible. Squares A and B, they are the exact same shade of gray. No, really, it's true. Go ahead, you can even pause and cover up the rest of the image with your finger to check. See? Your eyes aren't deceiving you. Your brain is.
And that leads us to the big question for today. Why? Why do our brains get this so spectacularly wrong? Well, to figure that out, we first need to understand how we see things in the first place. It all comes down to the huge difference between the raw data that floods into our eyes and the story our brain decides to tell us about that data. Think of it like this. Sensation, that's just your eyes detecting raw information. Light, colors, lines, it's kind of like a camera just recording a bunch of raw footage. But perception, that's what happens next. Your brain grabs all that footage, starts organizing it, and interprets it to create a story that actually makes sense. So sensation is the data, perception is the finished movie. And this whole process actually works in two directions at once. You got bottom-up processing, which is totally data-driven. It starts with your senses and shoots that information up to the brain. But then there's top-down processing, which is the complete opposite. Your brain uses everything it already knows, your experiences, your expectations, to interpret the data coming in. So here's the thing to remember. What you see is always a mix of what's really out there and what's already inside your head. So how in the world does the brain build that movie? I mean, how does it make sense of the absolute chaos of sensory info it gets hit with every single second? Well, it's got a pretty powerful toolkit for organizing the world. A huge part of that toolkit comes from this really cool idea in psychology called Gestalt. Now, it's a German word, and it basically just means form or whole. And the whole idea is built on a really simple but powerful premise. Our brains are literally hardwired to create order out of chaos. It's like the default software that's always running. The very first thing your brain does with any image, and this happens instantly, is separate an object, which we call the figure, from everything else, the ground. So when you look here, you probably see the firefighters as the main figure, right? But look closer. Your brain has to actively choose what to focus on. Our brains are also obsessed with finding patterns. I mean, without you even trying, your mind automatically groups things together that are close to each other or that look similar. It even fills in the gaps to create a complete shape, like it's doing with these circles to make a cube. This isn't a choice you're making, it's just your brain's automatic way of making the world feel a little less random. Now this gets even weirder with an image like the Necker cube. At first glance, do you see a 3D cube? Or do you just see a bunch of blue circles with some white lines through them? If you keep staring at it, you might feel your perception literally flip back and forth. That's your brain actively trying to assemble all these little pieces into a meaningful whole. And sometimes there's more than one right answer. It proves that perception is an active process, not a passive one. But your brain's goal isn't just to organize things. Its main job, its number one priority, is to build a stable, predictable world for you to live in, even when the reality all around you is constantly shifting and changing. And the way it does this is with a kind of superpower called perceptual constancy. This is our amazing ability to see objects as stable and unchanging, which is absolutely crucial for, not bumping into things, even when the raw information hitting our eyes is changing like crazy from one moment to the next. Just think about a simple door. You know it's a rectangle. That's easy. But as it swings open, the image that's actually projected onto your retina is a trapezoid and then just a thin little line. But you don't get confused, right? Of course not. Your brain knows it's still a rectangle and just automatically corrects the image for you. That's shape constancy in action. Okay, but our brain doesn't just use these hardwired rules about shapes. It also leans heavily on our personal experiences. This is something called a perception set. It's basically all our mental shortcuts, our assumptions, and our expectations that directly influence what we perceive. This is that top-down processing we were talking about in its purest form. For example, when you look at this picture, you don't just see yellow sticks in a red box. Come on, you see McDonald's French fries. Your brain instantly brings up all these expectations of salt, the smell, the crunch. That whole web of associations is your perception set, and it completely shapes your experience before you even take a single bite. Okay, so we've covered sensation and perception, Gestalt principles, and constancy. We now have all the tools we need. It is time to go back and crack the illusion code. So let's go back to our checkerboard one last time. Why on earth do squares A and B look so incredibly different when we know for a fact they are the exact same color?
The secret is one last type of this superpower we've been talking about. It's called color constancy. It's our brain's powerful, almost stubborn insistence on seeing an object as having one consistent color, even when the lighting around it changes dramatically. So here's the play-by-play of what's happening inside your head. Step 1. Your brain sees the shadow being cast by that green cylinder. Step 2. It uses all its past experience with shadows to assume that any surface in a shadow must actually be a lighter color in real life than it appears. And step 3. It automatically corrects your perception to account for that shadow, making you see square B as being way lighter than square A. Your brain is trying to be helpful, but in this one clever case, its shortcut gets it wrong.
So if there's one thing to take away from all this, it's this. Seeing is not a passive act of just recording what's out there. It's an active and constant process of constructing your reality. Your brain isn't just the camera, it's the director, the editor, the whole production studio, really. Which leaves us with one last, kind of mind-bending question. If your brain is actively editing what you see, making assumptions about something as simple as a shadow on a checkerboard, what else is it editing?